Summandum is a puzzle played in a square grid. The grid has some numbers and your goal is to establish addends that were used to make those numbers and place them on the edges of the grid. We know the addends on each side of the grid are unique numbers from 0 to grid size -1. Summandum puzzle is very easy to solve when 0 is present, but what if not? This time we'll look at a harder version of Summandum, with no 0. First of all, the presence of 0 in the puzzle means most sums have at least two possible versions. However, options for making sum values are still quite unique. Let's see this one here. It's clear it's made by a sum of 0 and 1. The part we need to establish is whether the 0 is located on the left edge or the top one. Let's assume it's located at the top. This will give us a 2 and a 1 on the left edge. Now we can also get a 3 from this row. And we have a problem. We've already used 1 and 2 on the left edge and 0 and 3 on the top edge. So we have no way left to make this the here, because it can be made only using 0 and 3 or 1 and 2. So, the 0 can't be located on the top edge, meaning our value on the top edge is a 1 and the 1 on the left edge is a 0. This row lets us place a 1 on the left edge and then a 4 on the top edge. And here's no more obvious values left again. However, let's get back to our 3 here. We already have 0 and 1 placed on the left edge, so the value on the left edge used to make a 3 can be either a 2 or a 3. However, we also have a 1 on the top edge, so a 2 won't work, meaning the value on the left edge here is a 3 and the 1 on the top edge must be a 0. Now we also found a 3 on the top edge. And nothing we can calculate again. However, let's take a look at the top row, or, more specifically, our options to place a 2 there. It clearly can't be located in column 1, because 13 would require an 11 and our maximum value of addend in this grid is 7. Similarly, it can't be located in column 4, because 12 would require a 10 on the left side. This leaves us with two placements that are legitimate, but in the long run the last column won't really work. If we place a 2 here, it would require a 7 on the left edge to make this 9. However, this 10 here would require a 3 on the top edge now, but we already have a 3 placed in column 6. Therefore, the 2 must be located in the second column, meaning the value in the fourth row is a 6. And now time to place a 2 on the left edge. Row 1 won't work because of this 13, row 3 won't work because of this 12, and row 7 won't work because of this 10. 10 minus 2 is 8, and our maximum allowed value is a 7. So we are left with a single placement option. And after the 2 is in place, we can use the 8 to place a 6 in the top edge. Using this 6, we can place a 7 and a 4 on the left edge, making the only missing value on the left edge a 5. And now we can fill the 2 remaining values in the top edge with a 7 in column 4 and a 5 in column 7. Done. This was significantly harder than a grid with an available 0, wasn't it?